Welcome to Commit and Push, the podcast about how great software really gets built. I'm Damien Filiatrault, your host and the founder of Scalable Path. Each episode, I talk with founders, developers, and leaders about the decisions, trade-offs, and hard lessons behind successful digital products. Let's get into it. All right, so today I'm speaking with Iddo Gino. Welcome to the podcast, Iddo.
Hey, yeah, thanks for having me. It's great to have this chat today.
Yeah, your career got off to a meteoric start when you founded RapidAPI in 2015 at just 17 years old. The company reached a $1 billion valuation at one point and was ultimately sold to Nokia. Can you tell us that story?
Yeah, it's I was kind of jokingly say I stumbled into the API space. But I, grew up overseas, grew up in Israel. Pretty early on in my childhood, kind of got into software development and writing code. So I think by the time I was 12, I was, back then writing a lot of code, either websites or using Flash and writing ActionScript and building out games. The first dollar I ever made was there was a point in time where you could actually compile Flash games into iOS apps. So the first dollar I ever made, or probably the first few hundred, was actually selling Flash-based iOS games in the App Store. This is around the time iPhone 3GS and iPhone 4 came out. So that was kind of my start into the whole world of technology. And then ended up playing around a lot with APIs. And for me, as somebody who was just getting started, I wasn't a phenomenal developer, probably still am not a great developer. But the idea of APIs where you can, sign up, get an API key, plug into a service, start making API calls and actually build really meaningful applications and have access to data and functionality that you could never build outside of using an API. That was really compelling to me. And my kind of first foray into the world was setting up a list of APIs. So V1 of Rapid, not a lot of people know this, but V1 of Rapid was actually a GitHub repo called Awesome APIs, and it was just a list of APIs. Over time, we started adding more documentation, examples, instructions. Eventually turned it into a website where you had more of an interactive playground and you can actually test out and interact and make API calls. And eventually met an investor who ended up, back then I kind of met him for advice, and he judged at some startup competition that I was pitching in. I actually pitched a different idea. And we're chatting through the, different things I've been working on. And got to talk about Awesome APIs, and he was like, hey, and for context, this is around the time when, Stripe just started raising massive rounds, and Twilio and SendGrid and, all these companies were growing. And he said, I think there is a real market here. If you'd be interested to turn this into a real company, I would love to be the first jack. And obviously I was 17 at the time. So obviously my first answer was hell yeah. My follow-up was, so how does one start a company? He actually introduced me to the lawyer who ended up registering the company and doing everything. But that was the humble beginnings of Rapid, and how we kind of set up to, we transitioned then from Awesome APIs to RapidAPI, it was pretty awesome, harder to brand around it. But yeah, we went from Awesome to Rapid. And then, the marketplace later turned it into a real business, and spent the next 8 years scaling it.
Cool. I mean, I read a bit about, how you were at one point, raised a round in 2022 with a super high valuation. Was that something that was, in hindsight, a good idea? Like, that getting such a high valuation, did that end up hurting you guys at all?
I think that, the valuation at the end of the day, it just ends up being a product of where the market was. I think it's more of a signal of where the market was at, more than anything. I think that there wasn't necessarily a huge impact. Obviously internally getting to that milestone and the unicorn club and everything, that was exciting. It may have helped a little with things like recruiting and building credibility with customers. This is also at a time when we already started focusing quite heavily on the enterprise side and upscaling our product. So having that kind of credibility and brand recognition really helped. But in retrospect, I don't think it had a huge impact, the valuation side, one way or the other, on the company trajectory.
Yeah, the company trajectory maybe, but as far as like stakeholders or stockholders getting, money back at the end on a sale, it might affect.
It would. And then again, without getting too much into technicalities, it's usually around how much money you raise, because most investors kind of have this provision where they get their money back, and you kind of start last to first. So it's more about the amount of money you raise, less around the valuation you raise it at. And again, with the amount of money, I think there was a lot of upside in terms of the things we're able to do. We, over the course of Rapid, did a handful of acquisitions. We're able to hire more people. We're able to hire really great people and build a lot of things. I also think that inevitably, when you raise a lot of money, you become a little spendful, and probably less efficient than you could be. So, yeah, definitely in retrospect, kind of a double-edged sword, if anything.
Mm-hmm. I mean, my company has used it. Do you feel that the legacy is being continued by Nokia, or are they changing it?
I think so. I mean, the Nokia relationship was interesting because they actually started by being a customer of RapidAPI. So this is how we kind of got connected with them, and started building the relationship. I think they have a really interesting kind of vision for how APIs and the kind of software layer plays into 5G and future networking technologies, which I think is really exciting. And I don't know, I feel like if they can build that with the help of Rapid, that ends up becoming a really compelling vision. I do, personally, I feel like a lot of that does end up ultimately coming at the expense of the developer platform that we built, which I think, and maybe we didn't remind ourselves enough of that, but the kind of core platform of an API marketplace where people can really easily publish and monetize APIs, and then other people can really easily connect to them and build amazing apps out of them, that may have gotten lost in the process, which is kind of unfortunate in retrospect.
Yeah. Well, that must have been an exciting journey. We could probably talk a lot more about that. And I do at one point want to talk about what you're doing now at Datawizz. But when we spoke last, you kind of said something kind of controversial, which was that you don't think that MCPs are necessarily a good idea. And I'm curious to hear more about that.
Yeah, happily. So, I think it's been obvious for a while, at least to me, that, and I feel like
I should have said this, but I'm going to interrupt you and say, just to be clear, I'm not going to just go into with an acronym. We're talking about Model Context Protocol, which was proposed and launched by Anthropic. And so I'm sure most people knew that, but let me just say that before I let you go here. Okay, cool.
Yeah, so Model Context Protocol basically is a way to create integrations between AI models or AI-powered assistants and other systems. And, I think it's been obvious for a while that the way to make those AI systems truly powerful, like to go from a chatbot to an assistant or to an agent, and you need to let those agents, A, be able to get context, so be able to fetch information, and B, be able to actually take action. So when I ask an agent, hey, like, the classic example, like I want to book a flight to Italy, it needs to be able to go and look at flight ticket prices, and then it needs to eventually be able to actually go and book the ticket for me. And I think that there have generally been kind of 2.5, 3 iterations in the market of our approach to doing that. The first one, which I actually think was both right and wrong, was OpenAI. If you remember, very early on with ChatGPT, they had the plugin marketplace where you can basically enable a bunch of plugins into OpenAI, and all of those were based on OpenAPI specs. So the idea was a plugin is essentially an API that the agent can start talking to. You give it the spec, and it can start talking to that API and taking action. Now, and the idea is really cool because if you can get that to work, there are tens of thousands. I mean, just on Rapid, we had, I think, over 50,000 APIs All of them have open API specs. So if you can get that mechanism to work, you basically unlock AI agents being able to talk to everything. The OpenAI version didn't really work that well in V1, and there was really two reasons for it. One was, I think back then, we're done in the era of GPT-3, 3.5. I think the models were not strong enough. I think it would have worked a lot better if you actually plugged in a GPT-4, GPT-5, Claude 4 into those API specs. But then the other thing that happened, and this is something that, kind of coming from Rapid, I feel like we learned the hard way over years, is most API documentation and APIs themselves are kind of built crappily. So you have APIs that are built, in theory, they're RESTful or GraphQL-based APIs, but they're built with, a lot of weird idiosyncrasies that are not industry standard. And then they have documentation that is not nearly up to date and not nearly as comprehensive as it should be for the API. So when all you give, and this has been a bane of, the bane of our existence as developer for the longest time. You try and integrate an API, nothing works like it should. Like the documentation doesn't actually cover how anything really works in practice. And it's really, and that's why integrating with APIs traditionally is really frustrating. And AI agents just had the exact same issue. Now, one way to solve this would have been to just make APIs better and improve API docs and catch the API specs where the APIs are. MCPs are kind of the different approach. They're basically saying, let's invent a brand new API standard and try to migrate the entire industry to this new standard. Now, obviously, at this point in time, it kind of initially it seems to work really well, which is what we're seeing now, because you get clean, brand new APIs with fresh documentation. There hasn't been any time for documentation drift. There hasn't been any time for spec drift. There hasn't been, V1, V2, V3 like you have with some older APIs. So right now things look great. The issue is with APIs, we've built decades of experience in how to manage, secure, and scale them. And there's a lot of tooling around it. There's, pretty mature API gateways. There's API authentication. We have standards around that. We don't have any of that with MCP. So now we're kind of at the point where we have to rebuild the entire API industry for MCPs. And nobody guarantees us that in 5-10 years, they don't end up becoming really disgusting again like a lot of APIs are. Because now we have this fresh, new, clean thing. And in a few years, you're going to end up with kind of outdated specs again. Anyway, I can keep going on this for a while.
Well, let's keep on it for a little bit here, because admittedly, I've been in this business for a long time, and for a long time I was saying, I still get in there and code, but I got to say I don't do it too much anymore, and I haven't personally, used an MCP service, but I've tried to keep up to date. And I mean, isn't it true that by design, it makes it easier for developers to use at least LLMs and chat-based services? I mean, the model context protocol is sort of designed for that, and to make that a little more simple for managing context than a regular standard REST API, for example.
It's not necessarily any different from a RESTful. I mean, you could make the argument that it's an API built to be consumed by AI. But then now, we have AI has a lot of training data on how to use APIs. It doesn't have as much training data on how to use MCPs. And then even if that's true, now you have a whole other type of API that you have to maintain. So now you have kind of two entry points. You have, your traditional API for regular applications, and then you have your MCP for LLM access. And the maintenance burden becomes, twice as big. So I'm not sure that maybe some slight, and I haven't really seen it with strong models, but that the potentially slight improvement in quality justifies what you're paying in maintenance and long-term costs.
Mm-hmm. I mean, do you think, obviously your background at Rapid and in the API world, brings you to this problem with a certain opinion, you've got a lot of insight into how APIs should be done. But do you think there's any part of you that's like, feels like I just spent so many years of my life building, a service to make traditional APIs better and awesome, and now like that is kind of not even being used, and that's frustrating. Is that like factoring into your sort of distaste for MCPs?
No, I don't think it. Well, it's kind of interesting because having been in the API industry, and this happens every few years, I think it's actually one of the ailments of the API industry is that we take really bad care of existing APIs. And then in terms of just maintaining them, every few years somebody comes up with a brand new concept that is real. I mean, that was REST, right? We had SOAP APIs, we had RPC, then there's REST, and then there was GraphQL, and now there's MCP. Every few years, because all the legacy becomes disgusting, instead of just keeping that legacy clean and well documented and well spec'd and usable, we just let it become this mangled mess and then just invent a brand new standard and everybody starts shifting to it. And initially it looks great. Like GraphQL initially looked great because everybody built brand new GraphQL services. And it was, clean slate design. Everything was like 1 to 2 years old max. So of course it looks great. But then you age it forward 5 to 6 years and they're about as messy as a lot of RESTful services and have a lot of the same issues. Only now we had to build a bunch of more tooling to also support GraphQL. MCPs are like, I feel like are going to end up in a very similar bucket. Like run it forward 5 to 6 years. They're going to be about as messy. And we'll have needed to kind of reinvent a lot of API tooling and security to support MCPs, which are a type of API at the end of the day.
Mm-hmm. I mean, I was talking to someone like 30 minutes ago and I was saying we were going to talk about this. And he was like, well, yeah, MCPs are actually implement the open API spec. Is that true?
I think yeah. I think, but it's not an open API. It's not a RESTful open API in the same way that you would also expose. I mean, this is the funny thing because it's actually, they are essentially APIs. We're just changing the semantics enough to have to build a brand new MCP-centric API.
So a quick pause here. I wanted to tell you a bit about why I started my software staffing company, Scalable Path. Back in 2008, I was working on a client project with some developers in Argentina, and I saw how amazing it was working with people in my time zone who were just as available as people in my office. So in 2010, I started Scalable Path to help companies take advantage of this underutilized talent pool. And since then, we've built a platform of over 40,000 developers, and we've placed over 600 of them with over 300 clients. So if you're looking to hire top-notch dev talent at a fraction of the cost of hiring locally, visit scalablepath.com/commit. And as a listener of the podcast, you can get 20% off your first month. I'd love for you to give us a try. And are these new MCP APIs only usable by LLMs, or it's like, are you going to have to maintain both like a traditional API for, developers using SDKs and then also this MCP for LLMs? Or will there be now SDKs that you could have in different languages that actually call the MCP?
It wouldn't be as the MCPs are very kind of well engineered for the LLM use case.
Yeah.
They're also in many, if you kind of, put together the Venn diagram for most platforms of MCP functionality and kind of traditional RESTful API functionality, there isn't a full overlap. There's actually a very partial overlap. And then, all of the integration tooling and SDKs and everything is built around RESTful APIs. So yeah, I don't think MCPs would just replace APIs anytime soon. I think you're just going to have now 2 integration flavors where, it's very similar. Like a lot of people start exposing GraphQL services at some point. But there's I can't even think of a good example for like a robust public API where GraphQL entirely replaced the RESTful API. Like, run it forward a few years, you end up maintaining both.
And are you arguing that if they had just tried harder with, say, REST APIs, that could have been the one entry point to most applications?
Yeah, I think REST-based integrations could have worked very well. Again, provided you have a clean, well-spec'd, well-documented RESTful API, which like you should, if LLMs can't integrate with your service or find your API to be a pain in the ass, your developers are going to have the same pain too. So if the byproduct is you have to go and clean your APIs, like that's a great byproduct to have of that transition.
And also with all these, I mean, I'm sure there's tools now based on LLMs that will help you write that documentation really easily too. Like, if you didn't even have any, you could probably just point an LLM at your API and then say, hey, can you write the documentation for this? Is that true?
Or here's the spec, here's the GitHub repo. Read the GitHub repo. Does it look like the implementation matches the spec? And like 9.9 times out of 10, the answer is going to be no.
Yeah, and then they could you could say, hey, update the spec, or at least give me a first draft of that. Would that work?
Yeah, and this is where we kind of grew frustrated over time, because at Rapid, APIs are only as useful as you make them, and we had to kind of beg people to clean up their APIs and make them useful for developers. And guess what? You make them useful for developers, they're going to be useful for AI agents as well. It's kind of a 2-for-1 instead of just reinventing this whole new standard. Anyway.
Well, it's an interesting perspective. I guess time will tell if it just becomes like another thing, and then there's another thing after that we have to maintain. We'll see. All right. Well, what are you doing at Datawizz now? Tell us about that.
Yeah. So for context, I had a new company called Datawizz about 6 months ago. We kind of started out of a realization that the way a lot of AI applications are being developed right now is not sustainable. First and foremost, not economically. And there was this meme that I just saw on Twitter this morning where it's like, you have a hooded person, it's like 100 million ARR, and then you turn off the hood, 120 million Anthropic bill. And that's, it's kind of a joke, but like that's really the state of a lot of AI applications right now. And then you're dealing with these huge generic models where I think we're hitting the ceiling of what you can jam into a generic model in a lot of industries. So the idea that every AI app is going to use one, either GPT or Claude or Grok or Gemini, and these are going to be these huge generic models that do everything from writing code to philosophizing in German, it doesn't make sense. We see a world where you can actually make AI consumption a lot more logical by creating smaller specialized models. So models that, the models we look at are between 1,000 and 2,000 times smaller than models like GPT and Claude, that can only do one thing, but can do that extremely well, in many cases even better than the original kind of large generic model, and then route requests to the right either specialized model or, for new novel use cases, LLM. So we help companies, so this is kind of a long way of saying what we do here at Datawizz is we help companies rationalize their AI usage and make their AI applications much more cost effective by being able to train in a bunch of these smaller specialized models. So these are basically distillations that are trained to do just one thing. And often these models are extremely narrow in their focus and what they're trained on, and then smartly routing requests either to one of those smaller models or to a large generic model if it's some new prompts or some new use case we've never seen before. And the impact that's able to drive is usually between 85 to 95% reduction in cost over just calling a traditional LLM.
Yeah, it makes a lot of sense. And I'm curious, when you say you're routing it, like, is Datawizz like a service where they send the prompt to you and then they're paying some sort of like fee, either like a monthly fee or per request fee, and then Datawizz is doing the routing, or are you just consulting with them to help them do the routing themselves, for different use cases?
Yeah, so we're a full platform, and we expose our router as an OpenAI compatible API. So if you're using the OpenAI SDK or something like LangChain or whatnot, you can just substitute that URL to go through Datawizz. we get the request, and then our system basically looks at it and say, hey, do we have a specialized model that we've trained for you that is going to be able to handle that request well? If so, route to that model. If not, fall back to whatever LLM you're connected to. But then we also log that request, so then if we see enough of those requests, we'll actually go and train a model to handle that subset. So if you start asking a lot of, help me rewrite this Python function type prompts, for example, the system will automatically go and say like, hey, seems to be a lot of volume there. Let's go and train a specialized model to do function rewriting in Python. And some of them are extremely specific, even more specific than that. And now you have this new model that can only handle that very specific subset, but it can do that with a few 100 million parameters, not a few 100 billion parameters.
Well, so are you also, like, what different models are available for this routing? Are you also routing between other commercially available models? Like, how smart is this router? Can you say like, can it look at the request and sort of say, I see what this kind of request this is, and then say, well, this would be good for Claude Sonnet because it's for coding, or this is about poetry, and so I'm going to send it over here, or or is it just like you have one default LLM, and then it's like if we customized a model for you, we send it there, and it's it seems like a mesh of all these techniques could be cool.
Yeah, and today we focus a lot about routing when the models are specialized and retrain them. And we're at a huge advantage because we know what we trained the specialized model on. So we can actually predict very well what it's going to be good at and what it's not going to be a good fit for. So that's been kind of our focus on the routing side. We do offer some very simple kind of rule-based routing between the larger models. But then there's other companies, there's Martian, there's Not Diamond, there's a few other companies in the pure kind of LLM routing space, which if what you're trying to do is smartly route between large models, I think they do a much better job of that. Where we focus is a lot of the kind of specialized models in routing to the right specialized fine-tuned model.
Mm-hmm. I mean, don't developers know by like what part of their app is calling a different model, like what model it should go to? Or what's a use case where you don't know what model you should be calling? Is it like maybe a chat where you don't know what the prompt is going to be from an end user? Or
well, it's more dynamic because you could do a lot of it deterministically. The value of the Datawizz platform is we're able to sit there as a proxy. So, if today you're just sending everything to an OpenAI or an Anthropic or a Gemini, which a lot of people are, it's an easy, one and done replacement. We start kind of building the data catalog and mapping out the clusters of similar looking requests. And then we automatically know, okay, in this cluster, we have enough volume to actually go and train a model. Let's train the model, evaluate it. And if it's good enough, we start routing requests to it. But the application doesn't need to be aware. So from an application perspective, using Datawizz is kind of like using a CDN. It doesn't need to be aware that anything has changed. That the fact that we know, okay, now there is enough data, we can go and train a model, we can promote it, and we can start routing to it. All of that is automated and kind of happens behind the scenes. So you could do that in theory deterministically. It will just involve a lot of overhead around the data collection, mapping out the models, and defining the routing logic.
And these custom models that you train, are there other commercial like products that do similar things, or are these like super custom based on client? Like they're so niche that like they don't exist in the market?
So what we do is when I say train models, we fine tune existing kind of open source models. Mm-hmm. So we will take an off the shelf model and we'll fine tune it. And we will use very specific customer examples, so a combination of real data we're seeing and some synthetically generated data to train those specialized models so they become very, it's also in traditional LLM sense, you would consider what we do to be kind of overtraining or overfitting, because we kind of overfit very specific to the very specific customer prompt and use case. But that's how we're able to get very good results with a very, very small model. And it counts on us having a router, so we only know to route requests to that model when they fit that kind of very specific narrow criteria.
As you may know, I run a vetted talent platform called Scalable Path, and I'm offering a 20% discount to listeners of the podcast. So if you're interested in scaling your dev team faster and smarter, visit scalablepath.com/commit. Mm-hmm. I mean, how much volume does a company need to have to where like this makes sense? You know, I guess if you're a low volume application where it's not happening very often, then going with something generic doesn't really hurt you that much because it's going to cost nothing to do development of the model. And if you got pretty low volume of requests, then okay, they're still just like what, pennies for a request. How much volume do you need to be a customer of yours, you know, and make this custom training? And another way to ask is this: how much does it cost to train these custom models to make that a good ROI?
Yeah, so I mean, typically we say what we kind of see with a lot of our customers today is they'll actually start building out the app or the feature by leveraging a large language model. Mm-hmm. It doesn't make sense to start out, as you said, with these specialized models because you're not going to have enough data to train them anyways. You don't have a good understanding of what the clusters in your use case are, and it's probably not worth the trouble because you wouldn't be spending that much on LLMs anyways. Typically what we see is when you reach the high hundreds of millions, or even more realistically, billions of tokens per month, that's when you should start thinking about the transit. And it also really depends because, you know, when we go and we kind of try to understand how sparse the use case is, so you could have, you know, billions. We've seen a case where there's billions of requests, or billions of tokens, but they're on widely different use cases. So, you know, it'd be really expensive to go and train all these specialized models versus, you know, out of the, you know, let's say you have 1 billion tokens, you know, half of them are on this one, you know, you're doing kind of data extraction from a web page, and it's always like a very similar looking web page because you're scraping the same platform. So those requests are extremely similar. And then we're going to be able to sub them into a tiny little model and save quite a bit of money there. So it is kind of use case by use case.
Well, that makes a lot of sense. You know, as you said, you know, there's a lot of money being spent on these LLM tokens, and I'm sure more and more companies are going to have to start optimizing that. So it's an interesting business you're in. How's that related to, you know, what's going on device LLMs? Are you guys doing that at Datawizz, or I know you're also interested in that area?
Yeah, and we've actually launched. So part of our view is, again, we think a lot of the inference is going to go, and that's something that I'm personally really excited about, is going to get closer to the client, and in many cases happen on the client already. So one of the things that we already do, it's not client inference, but a lot of our specialized models you can actually run on Cloudflare AI workers. So then we're able to actually bring the models themselves to the edge and to a point of presence much closer to the customer and get that inference latency down quite a bit. But then we also are now seeing a world where a lot of clients at the end, so like your iPhone, your Mac, your iPad, can actually, you know, the Chrome browser, they can actually run small models quite effectively. This is where you need those models to be specialized, because, you know, a 3 billion parameter is not going to be that great generically for tasks, but if you add an adapter and specialize it, it can be actually pretty powerful for a lot more tasks. So this is something that we are now offering in beta through the Datawizz platform too, is you can actually go and train adapters for small on-device models through the Datawizz platform. So for instance, the iOS 26 that is in beta now, so iOS 26 actually includes a built-in 3 billion parameter model. So it's out of the box, it's an okay model, but you can actually load your own adapters to fine-tune it to a specific task. And with that, we've actually seen it be really powerful for a pretty large set of tasks. So this is something that we make really easy to train and evaluate through the Datawizz platform as well.
So just to sort of spell that out in a different way. Like, let's say you've got a native app on iOS, and before you were sending API requests to, Claude or even to your service for routing, over the internet. And you're saying you could just have your application run a certain subset of requests on the user's device. You don't have to pay anything for that compute, and you could save a bunch of money and have really fast results. That's basically it in a nutshell?
Yeah. And it's obviously, it's the cheapest, it's free, it's fast because it's on device, and it's super private that your data never leaves your device.
Yeah.
And that's so iOS 26 has that model built in. The kind of alpha versions of Chrome have that too. So there's a Gemini Nano model built into Chrome that you can also load kind of adapters on top of.
Is that also on phones? So you'll be able to do that with web apps too, you're saying, not necessarily just native apps.
Yeah, and so far we've seen it with Chrome Desktop. I think, all of this is kind of cutting edge. I think it will arrive to Chrome Mobile too. But yeah, I think that give it because you now have pretty powerful discrete graphics on even most mobile devices. I think it's going to be pretty quickly where we get to the point where every platform where applications run, there is access to some sort of built-in model, and there's the ability to load adapters on top of it to customize it and specialize it for a specific use case.
Cool. Well, this is good stuff to keep in mind for developers to optimize their usage of AI. Anything else you want people to know that you're working on or thinking about?
No, I guess one thing I'll put out there is we do have a very generous free tier with Datawizz. So anybody thinking about, especially with Edge AI, kind of training and fine tuning these models, definitely do head over and check out datawizz.ai. But yeah, other than that, if anyone is building something really interesting, especially around the kind of edge and client stuff, which we're really excited about, we would love to learn about it.
Great. Well, it's a pleasure having you on, man. Got a lot of good knowledge, and thanks for coming on and sharing it.
Yeah, this has been a great conversation. Thanks for having me.
Well, that's a wrap on this episode of Commit and Push. If you found it valuable, subscribe on Apple Podcasts, Spotify, or YouTube. And if you're building a team, check out scalablepath.com to find top developers. Until next time, keep building, keep pushing.